Question 3.30. A 10-volt battery is connected to two parallel plates placed in vacuum. An electron is accelerated from rest from the negative plate towards the positive plate. In the first part of the question, we need to find what kinetic energy does the electron have just as it reaches the positive plate. So let us first write down what is given to us. We have a 10-volt battery connected to two parallel metal plates. So potential difference between the two plates will be 10 volt. Then you have an electron accelerated from rest. Since it is accelerated from rest, its initial velocity will be 0. And if its initial velocity is 0, initial kinetic energy will also be equal to 0. And since we have an electron here, charge on the electron q will be equal to negative E, which is negative 1.602 times 10 to the power negative 19 Coulomb. In the first part, we need to find what kinetic energy does the electron have just as it reaches the positive plate. Now we know from work kinetic energy theorem, work done is equal to the change in kinetic energy. And this work done can also be written as negative of the change in potential energy. And we know that change in potential delta V is related to potential energy as delta U over Q. So I can write delta U to be equal to Q delta V. Let's substitute this here in our expression for energies. I write negative Q delta V equals delta K. Delta K is nothing but the final kinetic energy minus initial, which is equal to minus Q delta V. Let's substitute to find the final kinetic energy. K final minus initial kinetic energy is 0 equals negative. Charge on electron is negative 1.602 times 10 to the power negative 19. And change in potential delta V is 10. When you solve this, you get the final kinetic energy of electron to be equal to 1.602 times 10 to the power negative 18 joule. In part B, they want us to find what is the speed of the electron as it reaches the positive plate. And this is the final speed of the electron. Since we already have the final kinetic energy, we can find the final speed by using the relationship between them. We know that kinetic energy can be written as half mv squared. I want to find what is V final, so we will rearrange the term here. I will multiply with 2 on both sides and divide with m. So we get V final squared equals 2 times K final over m. We want to find V final, so we take square root on both sides. V final will be equal to square root 2K final over m. Let's substitute the values to find velocity. Square root 2 times kinetic energy is 1.602 times 10 to the power negative 18. Mass of electron is a constant and it is given as 9.11 times 10 to the power negative 31 kilogram. Substitute that here. 9.11 times 10 to the power negative 31. And when you solve this, you get the speed of electrons to be equal to 1.875 times 10 to the power 6 meter per second, which you can round off to 1.88 times 10 to the power 6 meter per second. You can also use shift solve at this point here to find your velocity V final if you do not wish to rearrange. And mass of electron again will be a constant, which is 9.11 times 10 to the power negative 31 kilogram. And final kinetic energy we already found in part A.